So moving on to the next part of the question, it's asking me to distinguish between interference and diffraction. Well, basically, all I've got to do there is just give my definitions. These are definitions that you will have learned very well at this stage. They're also asking me, can a diffraction grating which diffracts light? And what I mean by light there, what they mean by light there is visible light, because X-rays, they're also light because they travel the speed of light, but they're not visible. So can a diffraction grating which diffracts visible light also diffract X-rays? And we've got to justify our answer for that. Okay, so first part of that is just write down your definitions. So give the definition for interference. Let the word in my head, I always have a word for every definition. The word in my head for that is waves overlapping. The word I have in my head for diffraction is waves spreading. So once I have those key words, I'm most of the way through my definition. So interference is what results when waves from two or more coherent, I like to get that word in, coherent sources overlap and then combine to form a new wave. So that's interference. It's waves joining together to form new waves. And then what about diffraction? It's the spreading, get that word in, spreading of waves around corners or through gaps. So you're getting 6 marks really for the definition in each case. Next, they're asking me the question, can a diffraction grating which diffracts light, visible light, also diffract X-rays? Well, the answer is no. 3 marks for saying that. And now, what's my justification? Well, we did this very well in the lessons. We talked about good diffraction takes place when the size of the gap is approximately the same as the size of the wavelength passing through. Then you get really good diffraction. If that size of the gap and the wavelength are way apart, you get very poor diffraction or no diffraction at all. So my first sentence is good diffraction occurs when the distance between the slits in the grating is approximately equal to the wavelength of light passing through it. That's my first sentence. My next point is, X-rays and visible light have wavelengths that are vastly different. They differ greatly. The wavelength of X-rays is much, much smaller than visible light. So if the wavelengths are very different and we're using a particular diffraction grating, then the answer is, therefore, diffraction of X-rays will not occur with that particular diffraction grating. So get all of those points in for 6 marks. Right, back to my question. So they're asking me, in the last part of the question, it says light travels as a transverse wave. Name another type of wave motion and give 2 differences between these 2 types of wave motion. Again, you're talking about definitions. This question is just full of definitions. The definitions, when you present them, will give you the answer. So, we have transverse waves, of course, and you know what the other type of wave is? The other type of wave is a longitudinal wave. Sound is an example of a longitudinal wave. So 3 marks for saying that. So finally, they're asking me for 2 differences between my 2 types of wave, transverse wave and longitudinal wave. Well, the first difference actually will be in the definition. What's the definition of a transverse wave? It's where the displacement of the particles is at right angles to the direction of travel. And what's the definition of the longitudinal wave? It's when the displacement of the particles is parallel or in the same direction to the direction of travel. So your first difference actually just comes from your definition of what a transverse wave is versus a longitudinal wave. And then take a second difference, which is a property of these waves. Transverse waves, like light waves, can be polarized, whereas longitudinal waves, sound waves, they cannot be polarized. So that's my second difference. That was quite a short question and not too difficult. It was really full of definitions. The intelligent part of it wasn't exactly too taxing. So the question I'm looking at from Light and Sound from the Leaving Cert is question number 7 from the year 2012. It's a full 56-mark question, and you'll get 20 minutes max to do it. But this question is actually very short, so you'll probably get it done a lot less time than 20 minutes. So let's have a look at the question in our notes. It's all about the electromagnetic spectrum. So they give you a diagram of many of the parts of the electromagnetic spectrum. So the electromagnetic spectrum is all light. Some light you can see. This part here, visible light, you can see they're the colours of the rainbow. And then all the other colours, even though they travel at the speed of light, which is 3 by 10 to the power of 8 meters per second, your eye can't see them. So they're asking me to name the sections labelled A and B. Well, you need to know what are the radiations to the left, part A, and to the right of visible light. Now, I think I know they're infrared and they're ultraviolet, but which is which? Well, ultraviolet causes sun tanning. That's a lot more dangerous than infrared. And as you kind of go this way, it seems to be more dangerous, X-rays, gamma rays. And as you go the other way, it seems to be less dangerous, radio waves and so on. So I'm guessing, therefore, that A will be infrared and B will be ultraviolet radiation. So A is infrared for 3 marks, B is ultraviolet for 3 marks. They're asking me, how do I detect these radiations? Well, infrared are heat waves. So you can say infrared causes a rise in temperature in thermometers. So mention thermometer, 3 marks. Mention rise in temperature, 2 marks. So 5 marks altogether. Ultraviolet, what that does is it causes fluorescence. Causes fluorescence in something like Vaseline or white shirts that have been washed using a detergent. So mention Vaseline, 2 marks. And mention that it causes fluorescence, 2 marks. So very straightforward. Altogether, for just this very simple knowledge, we have 15 marks so far out of 56. Let's go on to the intelligent part of the question. Really, you don't have to be that intelligent to do this part of it. It says, an electromagnetic radiation has a wavelength of 4 meters. Name the section of the electromagnetic spectrum in which this radiation is located. Okay, so let me do the problem. First of all, I want to use my wave equation. Write down your wave equation. C is equal to F lambda. That's in your table look. And you'll get 3 marks immediately out of 9. We are told that the wavelength lambda is equal to 4 meters. We can find in our table book that the speed of light is 3 by 10 to the power of 8 meters per second. And what am I asked to do? I'm asked to find the frequency F. So F equals question mark. So a very simple problem. So manipulate the formula to get F on its own. So F is equal to C divided by lambda. C is 3 by 10 to the power of 8. And lambda is 4. So put that into my calculator, and I have the frequency of that particular radiation. Scientific notation, I'm going to get 7.5 by 10 to the power of 7. And make sure you write down the units for frequency. The units for frequency are hertz. But then I'm going to go back to my diagram in my notes and check out where that is, the name of that particular radiation. Go back to my notes. You can see down along the bottom here, you've got all the frequencies written down by their powers of 10. Well, I'm looking at, 7.5 by 10 to the power of 7? So I'm talking about along here. Somewhere between 10 to the power of 7 and 10 to the power of 8. Probably closer to 10 to the power of 8. Somewhere in here. We're talking about, and they'll take either answer, we're talking about either radio waves or TV and FM radio. So that'll be my answer there. As I said, they will take either in the answer. So we're talking about this being a radio wave, or we're talking about it being a TV or FM radio. That's the name of my radiation.